We're now going to go on to a more complex use of factorization, where we're going to need to factorize in order to multiply algebraic fractions together. So as we can see here, we've got an algebraic fraction multiplied by another one. At this stage, if you think of multiplication of numeric fractions, the method that we use is cross cancellation or cross multiplication, where we're looking for something in the numerator that can cancel with something in the denominator. So this is where people might be tempted to say a squared goes into itself once, a squared goes into itself once, but that is mathematically illegal, because you would then be cancelling across a minus sign. And we can only use cross cancellation when there's only the two operations of multiplication and division involved. So the first thing we need to do here is to factorize everything that we can in the numerators and in the denominators. So let's look at this numerator. I think obviously both terms have got a common a. So I'm going to take out a, and in my brackets I'll be left with b minus, remember that means a times a, so I've taken one of them out and I'm just left with b minus a. My denominator, b squared minus a squared. I hope by this stage you're noticing straight away two terms, a minus sign, perfect square, so we have dots. So it's going to factorize into two brackets. Square root of b squared is b, square root of a squared is a, and then remember with dots, one bracket gets a plus and the other bracket gets a minus. Times, let's look at this numerator. Again, very obviously a common factor of b, and I'm left with b plus a. And in the denominator I have a single term, so I can do nothing with it. It will remain a squared. So because we've now factorized everything, we can look for brackets that are identical. So b minus a, they are identical brackets. They each go into themselves once, or the way we do it is simply to cancel them out. b plus a, identical brackets. And remember, one must always be in the denominator and one in the numerator. Here I've got a, and here I've got a squared. So if I remember that a squared means a times a, that a goes into itself once, and I'm left with just a there. So the easiest is just to cancel out the squared. This b can't cancel with anything in the denominator. So now my tidying up step is where I'm simply going to see what's left over in the numerator. Here I'm left with 1 times b, which is b. And here I'm only left with a. So my final answer is b over a. Right, let's have a look at another one where we've got some different forms of factorization occurring here. So again, starting in the numerator, I've got a common a and also a common b. Remember, even though that's a squared, I can only take out a to the power of 1 because I'm always looking for the lowest exponent to take out as a common factor. So ab will leave me from this term with a, and then here I've taken out the entire term, so we're actually saying ab divided by ab is 1. My denominator, I only have one type of variable here, so I can take out an a and I look for the lowest exponent. That's my lowest exponent, so I'm taking out a squared. From there I'm left with a, check back, a times a squared does give me a cubed, and here because I've taken out the whole term I'm left with plus 1 times, in the numerator here I can take out a, meaning a to the power of 1 because that's my highest exponent, and I'm left with a squared. Remember, when we're dividing, a cubed divided by a, we subtract the exponents, so 3 minus 1 gives me 2, and a divides into a once, so I'm left with minus 1. If we look at this, we've got 3 terms, so immediately that's looking a little bit like a quadratic trinomial, but we've got this b hovering in all 3 of the terms, so we're going to need to take out a common factor first of b, and then I'll be left with a squared minus 2a. I took out the entire term, so I'm left with plus 1. Right, so now it's not looking great because I have an a plus 1 here and I don't have an a plus 1 anywhere in the numerator, the same thing there. So when that happens, you need to really look and see, can I factorize anything further? Well, obviously these very simple binomials can't be taken further, but let's look at that bracket. That bracket is saying a squared minus 1, I've got a difference of 2, that's a perfect square, and 1 is a perfect square because 1 times 1 will give me 1. So that's going to factorize further. Remember again, don't stop writing things down. If they're not needing to be changed, then you need to just write them down in the form that they are, because you're going to need to use them later. Right, that a has to stay there because you've taken it out as a common factor. And then my difference of 2 squares is going to factorize into 2 brackets. Square root of a squared, I'm going to have a square root of 1, and one bracket gets a plus and the other one gets a minus. Here I have 3 terms, and now that I've taken out the common factor of b, I definitely do have a quadratic trinomial. So leaving my common factor there, I know that this is also going to factorize into 2 brackets. Some of you might notice straight away that it's actually a perfect square trinomial, but if you haven't, I'm going to have a times a. What are factors of 1? Well, I only have one possibility, and that's 1 times 1. And can 1 and 1 give me 2? Yes, they definitely can. So I'm going to break my 1 up into 1 times 1. This tells me both signs in the brackets are the same, and they're both negative. So I could have written this as a plus 1 all squared, but for those who couldn't spot it as a perfect square trinomial, this is how you would have ended up. So now that everything is factorized, this is the fun part where I just start looking for things that can cross multiply or cross cancel. But remember, it must be numerator with denominator. So a minus 1 bracket, a minus 1 bracket, a plus 1 bracket, a plus 1 bracket, another a minus 1, a minus 1. Then I've got a b and a b. And here I've got a times a, which actually means a squared. So the a times a could altogether cancel with the a squared. So a times a, which is a squared, cancels with a squared. So I appear to have cancelled everything out, but remember what's actually happening is you're saying a minus 1 goes into itself once, and a minus 1 goes into itself once. So even though we don't write all those ones down when we're cancelling, they are all ones, and so therefore I have 1 times 1 over 1 times 1, which means that I have an answer of 1.